What if your VoIP calls keep dropping while big downloads hog all your bandwidth? The culprit? Your network treats all traffic equally until now. Discover how QoS tools like classification, marking, and priority queuing can eliminate lag and dropped calls. Stick around to see the game-changing low-latency queuing technique that Fortune 500 companies use. The tools of QoS. In order to be able to give certain packages a better treatment, it is first necessary to be able to identify them. This is called classification. Classification can be done in several ways. The most common is to use an access list to match certain values of the IP packet, such as source and/or destination addresses, or port numbers. For example, an access list that matches the TCP/80 destination port can be classified as HTTP traffic. After classifying the type of package, it is necessary to be able to mark it. Markup is the modification of one or more fields in the header of an IP packet or an Ethernet frame. For example, in an IP packet, it will be the TOS type of service field that will be used to mark the packet. And in an Ethernet frame, since they don't have a TOS field, the marking will be done in the tag field that is already used to mark trunks and VLANs. Here's an illustration to help you visualize classification and marking. On this topology, we have a switch, a router, an IP phone, and a PC. The switch receives packets from the IP phone and the PC. IL is configured to classify these packets using an access list on its interfaces. The switch then marks the IP packets using the TOS field in the IP header. So a small particularity for IP phones is that they mark their packages themselves at the time of their creation. It is preferable to use tagging instead, because the classification, which is done using access list, can become quite complex and degrade the performance of the router or switch that does this classification. On the topology, the router receives marked packets, so it does not have to perform complex classification using access lists, as the switch does. Another tool very useful for classification is NBAR, Network-Based Application Recognition. It is a tool that is able to detect network traffic applications using the content of IP packets. This allows for a better classification compared to an access list. Queuing and congestion management. Each network device uses queuing. When a router receives an IP packet, he checks his routing table, chooses the output interface to use, then tries to send the package. But when the chosen interface is busy, then the packet is placed in a queue, waiting for the interface to be available. This rule of waiting an IP packet on a router also applies to switches with Ethernet frames. And here's a representation of the hold process. Here, the router, when it receives a packet, it can do one or more input actions. For example, it can be an input access list that filters the packets. As soon as the router decides where to forward the packet, it can perform one or more egress actions, e.g., NAT. The packet is then placed in an output queue, waiting for the interface to be ready to be transmitted. So here, we don't have only one queue of outputs, so all packets are processed on a first-come, first-served basis. Remember, this is the concept of FIFO, first in, first out. There is only one queue, and everyone has to wait in line. Fortunately, most of today's network devices allow for multiple output queues, as shown in this new representation. Here, the router will use the classification to decide which packets go into which queue. How queues are processed depends on the scheduler that is used. Round, Robin scheduling is an algorithm that goes through the queues in order, i.e. in turn. For example, on the diagram, it will take a packet from each queue, starting with Q1, then Q2, then Q3, and then starting again with Q1. The round robin also allows you to favor certain queues. This is called weighted round robin. That is, it will take 3 packets in output Q1, 2 packets in output Q2, and 1 packet in output Q3. Then it will return to the front page with the same procedure. Cisco routers also use a very popular scheduler, which is called CBWFQ, class-based weighted fair queuing. It guarantees a minimum bandwidth on each class in the event of congestion, i.e., saturation of the queue. For this, it uses weighted round-robin scheduling, allowing you to configure. This weighting is a percentage of interface bandwidth usage. For example, in the diagram, we can see that the classifier sends packets to the different queues, and each queue has a different percentage of the bandwidth. In case of congestion, Q1 gets 55% of the bandwidth, Q2 gets 30%, and the 3 at 15% of the bandwidth. Low latency queuing. Round-robin scheduling works great for data applications because it ensures a certain amount of bandwidth for each queue. But this doesn't work for traffic, which is sensitive to delays, such as VoIP, voice over IP. Because in round-robin, when the scheduler empties queues 2 and 3, well, all the packets that are still present in Q1 is still waiting to be served. This adds delay. For this reason, this strategy does not work for voice traffic that is sensitive to delay and jitter. This type of traffic should be sent immediately and should not wait. To resolve this issue, a priority queue must be added. On the new schema, we can see that the first queue is now attached the LLQ low latency queuing process. Each time a packet is added to output Q1, it is immediately transferred, and all other queues must wait. So, it's important to set a limit on the priority queue, because otherwise, it's possible that the scheduler will be so busy transmitting packets from the priority queue that the other queues will never be processed. And when these queues are full, then the packets are directly deleted. Prioritizing a queue adds another problem. Now imagine that you have so much voice traffic that it saturates the priority queue. Well, the extra packages will also be deleted. This would affect voice calls enormously. This problem, which can be solved in Amoon directly on the PABX, Private Automatic Branch Exchange, with a function that controls calls, and which can be found in the settings of the telephony server under the initials of CAC, Call Admission Control. This function, which can be set directly on the PABX, allows you to limit the number of simultaneous calls. For example, if it is configured to 15 simultaneous voice calls, then the 16th call will receive a busy tone or will be dialed to the traditional telephone line, i.e. that of the Public Switch Telephone Network, PSTN, Public Switch Telephone Network.